Okay, we're going to look at 5.3, graphing radical functions, square root functions. If a function contains the square root of a variable, it's called a square root function. The square root function is a type of radical function. Alright, this is the parent function, f of x equals square root of x. So if you were graphing this by hand, you would only take square roots of numbers you know, like 1. Square root of 1 is 1, so you have that point. Square root of 4 is 2, and the square root of 9 is 3. And notice there are no negative numbers because a square root of a negative is undefined, okay? Or it's a non-real answer, so it doesn't appear on the graph. So the domain, the x values go from 0 to infinity, and the range also goes from 0 to infinity. This goes up forever. Alright, everything that we learned about transformations still apply to square root functions. So square root of x plus 4, what's the transformation? This is up 4. Okay, so where the 0 was is now going to be up 4. Alright, so then you could go over 1. Square root of 1 is 1, so I could go up 1 from there. I could go over 4. 1, 2, 3, 4. And then the square root of 4 is 2, so I'm going to go up 2 from there. And I'm going to go over 9 to go up 3. Alright, so I could graph the function. Okay, likewise, minus 4, this is going to be down 4. Alright, so same thing, this would be my starting point. Go over 1, up 1, go over 4, and up 2 from where I started. Go over 9, and then up 3. Alright, and then graph my curve. Alright, so that's what it would look like. Alright, when I directly add to x, it's going to move it left or right. So a plus 4 is going to go left 4. So we're going to start here. Over 1, up 1. Over 4, up 2. Over 9, up 3. And we'd have to go over 16, which doesn't fit on the graph. So, all right, so there's our curve. All right, this is going to be right 4. Up 1, over 1, over 4, up 2. All right, we're not going to have room to do any more. All right, so there's our function. All right, so that's what they look like. The same techniques used to transform the graph of other functions you have studied can be applied, as I just mentioned. All right. So this is our general form, and A is going to cause it a stretch. All right, if it's negative, it's going to be reflected over the x-axis. All right, the h is going to move it left or right, and the k is going to move it up or down. All right, the minus 2 is going to go right 2. And plus 5 is up 5. So we're going to go up 2, right 2, up 5. So this is my starting point. All right, there's no multiplier in front, so go over 1, up 1, go over 4, up 2. All right, I have to go over 9, that would be at 11, so it'd be off the graph. All right, so there's a rough sketch of our graph. All right, we'll state the domain and the range. So the domain here would be starting x equals 2 to infinity. And then the range, the y value starts at 5 and goes to infinity. All right, so plus 3, that's going to go left 3. And then down 1. All right, left 3. Down 1. So we're going to start here. So over 1. All right, so there's a negative here also. So it's reflected over the x-axis. All right, I didn't see that. Okay, so what that means is every time I plot a point, I multiply by -1 for my transformation. So let's erase this one. All right, so when we go over 1, when we go over 1 from here, instead of going up 1, we're going to go down 1 because it's negative. All right, and we're going to go over 4. And instead of going up 2, we're going to go down 2. And we're going to go over 9. 9, it will be 6. It will be down 3. All right, so here's our graph. So our domain is going to start at -3. Okay, with the bracket, and it's going to go forever. And then the range, all right, so this goes down forever, so the range, the smallest value is going to be -infinity. And then it's going to go up to -1. All right? All right, well, that's pretty much it. And we're going to stop the video here.